Okay, here's the thing, pair share. Pause the video, try this on your own. Come back if you want to see my solution. Okay, if 230 out of 600 teenagers plan to see the new Hunger Games movie, find a 90% confidence interval estimate for the percentage of all teenagers planning to see the movie. The movie theater claims that 25% of teenagers are planning to see the movie. Does their claim appear to be correct? All right, so let's look at our givens here. So going to see the movie, we're going to consider that a success. And that was going to be 230. And the total number is 600. All right, find a 90% confidence interval. So the confidence level is 0.90. And make sure you don't write this down without thinking what's going to be the significance level here. It's going to be 0.1 because it has to add up to 1. So we'll divide that in half, 0.05. Um, all right. Uh, so the movie theater is claiming that 25% of teenagers are going to see this movie. So we want to see if 25% is inside of our confidence interval or not. Okay, what do we need? So we need a proportion of success plus and minus error. And we don't have either. So to get the proportion of successes, that's the number of successes over the total number, which is going to be 230 all over 600. And let's see what that comes out to. Okay, 0.383. At 383 or 363? 383. Okay, sorry. And I'm going to store that in letter P. And then we need to have Q prime. That's 1 minus P prime. And let's see here. First, let me store this number. And I'm going to store it in capital P. And then I want to do 1 minus the answer. Okay, 0.616 or 617, but 616 and some change. Let's store that in Q. Okay. So 0.617. All right, so there's Q. Oh yeah, and I stored that in letter Q. That's good. Let me catch things up here on the Texas Instruments side. So we've got 230 divided by 600. And let's store that in letter P. We want to do 1 minus the answer. And let's store that in Q. All right. All right, so now we've got our point estimate for the proportion of the population of all teenagers. So now let's calculate error, which is Z alpha 2 times the square root P prime Q prime divided by N. And let's see, I think I got enough room here. We got to figure out what Z alpha 2 is because we've got everything else. So let's go ahead and draw. Just make sure when you're drawing this that you just don't fall under the trap of just repeating previous patterns. Because what you'll notice is that this confidence level is different than the previous examples. It's 90%, not 95%. So you could catch yourself falling into the trap of just writing like 95% there and putting in the wrong area here in the tails. So pay attention to all the details. And I'm not perfect, okay? I sometimes fall under that trap myself, but that's the reason why I'm warning you of it. It's because it happens to me too. All right, so we'll use an inverse distribution function to get our Z alpha 2 score, which is our critical value. Um, so for this one, I'm going to use my program, inverse n, because it should store the value in Z for me if I use it. So I'm going to do 0.05, mean of 0, standard deviation of 1. And I want the area to the right. Okay, 1.645. And I can check. That should be what's stored in variable Z. It is. Okay, let's do the same thing here. Go to the distributions app. And yeah, we want a normal distribution, which is fine. Area to the right. But the area is going to be 0.05 now. And we get 1.645. So I'm going to store that in variable Z. Okay, so 1.645. So let's write that down. 1.645. 1.645 times the square root of p prime, which is 0.383, q prime, which is 0.617, divided by n, which is 600. So let's put all of that in. Okay, so let's go to calculation app. And we want to do our Z alpha 2 score times the square root. And in the numerator, we've got P times Q divided by our N, which was 600, right? Yeah, P times Q divided by the square root of all that, and then Z. Okay. And we'll copy that over here. So we want Z times the square root of P times Q divided by 600. All right, so if we hit enter, we hit execute. Yep, we're getting the same answer. So 0.0326 and some change. So we get 0.0326 and some change. I'm going to round that to 3 decimal places. So it's going to be 0.033 for the margin of error. So the confidence interval of P prime plus and minus E is going to be 0.33 plus and minus 0.033. And it's a little easier to think of this in terms of percentages. So that's 38.3 per, oh, almost put percent there. 38.3 plus and minus 3.3%. All right. So let's create a number line where the middle of this is 38.3. And if we add 3.3, So that's going to give us what, 41.6%. And then if we subtract 3.3, that'll give us 35.0%. So this is our confidence interval with a 90% confidence level. All right, so this is the information based off of our data. And with a 90% confidence level, we expect 9 intervals out of 10 to include the population mean. So the percentage of all teenagers going to see this movie should be somewhere between 35 and 41% with a 90% level of confidence. But we can see here that the movie theater is claiming that it's going to be 25%. And so 25% is way down here. It's not in that confidence level. So um, what we can say here as a conclusion is that the movie theater's claim of 25% is contradicted by supported evidence. To a 90% confidence level. Um, so we'll put the actual percentage of moviegoers is higher than 25%. So that's our overall answer here. Okay, so this concludes this example. Let me know if you have any questions.